Good day everyone and welcome to our statistical analysis for industrial engineering. So we're going to have our lesson 4. It's all about the continuous probability distribution. It is under the chapter 2 of the probability distribution of random variables. To begin with our discussion, we're going to have our introduction. After learning the common probability distribution involving discrete random variables, this unit now discusses the common probability distribution involving continuous random variables. There are instances in science and engineering where continuous random variables are used. Because the number of possible values of a random variable is uncountably infinite, it has a distinctly different distribution from the discrete random variables studied previously. But as in the discrete case, many physical systems can be modeled by the same or similar continuous random variables. These random variables are described and for example, the computation of probabilities, means, variances are provided in this unit. This unit has one lesson but has three important topics. So for our objectives of our discussion, so you're going to understand or you should be able to do the following. Understand the assumption for some common continuous probability distributions. Number 2, select the appropriate continuous probability distribution to calculate the probabilities in specific calculation or applications. So number 3, calculate the probabilities, determine means and variances for some common continuous probability distributions. Number 4, standardize normal random variables. And lastly, use this table for the cumulative distribution function of the standard normal distribution to calculate the probabilities. So in this topic, you will be able to see the different normal curves at the same time the distribution function table you're going to use for every computation or calculation of the given problems. So we have the type of continuous probability distribution. So we have the uniform continuous, we have the exponential, and we have the normal. So for the uniform random variables, a continuous random variables has a probability of 0 of assuming exactly any of its value. Consequently, its probability distribution cannot be given in tabular form. However, it can be stated as a formula called the probability density function, or the probability that a continuous random variable assume a value between a and b is equal to the area under this density function between the ordinates x is equals to a and b is equals to b. X rather is equal to b. This is given by integral of the function from a to b, since areas will be used to represent the probabilities, and probabilities are positive numerical values. The density function must lie entirely above the x-axis. A density function is constructed so that the area under its curve bounded by the x-axis is equals to 1.0 when computed over the range of x for which the f of x is defined. So for you to understand those lessons, we're going to have a sample problem later on. So for uniform continuous distribution, one of the simplest distribution in all statistics in the continuous uniform distribution. This is used when an event occurs with equal probabilities between two extreme values. The distribution is characterized by a density function that is flat, and thus the probability is uniform in the closed interval, say that function of the a and b. It is also called the rectangular distribution because of the function is determined by a rectangle which is a base b minus a and a constant height of 1 over b minus a, the density function of the continuous uniform random variable x on the random interval of a and b. So we're going to have your probability density function. So this is your going to use. So we have the function of x, 1 over b minus a. So therefore the a is less than x is less than b. So we have the commutative distribution function. So if we're going to expand this one, so ibig sabihin we have the x sub 1 and we have the x sub 2. So in differential, so this will be your limit and this will be your upper limit. So therefore 1 over b minus a, so we have the derivative. So equals to quantity of x minus a over b minus a. Then we have your a. So your a must be your x is less than a, and we have your a will be less than equal to x or less than b, and b must be less than or equal to x. So by getting the mean, so we have the a plus b over 2 and the variance of b minus a quantity squared over 12. So let's have a given example. So for example, a bus arrives every 10 minutes at the bus stop. It assumes that the waiting time for a particular individual is a random variable with a uniform distribution. So A, what is the probability that individual waits more than 7 minutes? What is the probability that individual between 2 and 7 minutes? So for letter A, you're going to have your x and y-axis. So automatic from 0, so we have 7 and we have 10. So this is the time arrival from 0 from 7 minutes to 10 minutes. So we're going to use the initial of 7 and the maximum or the upper will be 10 by following the probability density function formula. So we're going to arrive at 1 over 10 minus 0. So what will be the formula? So your 0 will be your a, so that will be your initial. So a, this will be your a, so that is equals to 0. So therefore your result will be undergo to x. So following the derivative, so 0 is starting pa rin sa 0, so 7, so that will be 7, so that will be equal to 1. Then minus the x minus a, yung x mo will be your 7 and a will be 0, so from the initial point. So therefore b, so your b will be 10, this be a b, so b will be your 10 and a is 0, so therefore you're going to have your 3 over 10. Or if you're going to use the function of x is greater than 7, 7 will be your initial and 10, so therefore you'll be undergo to b minus x. So b will be 10 minus x will be 7, so 3, or b minus a equals to 0, so almost the same of your answer. Okay, for letter B, what is the probability that individual waits between 2 and 7 minutes? So if you're going to use 2, so as 2 as your initial point, 0 will be your initial point, and 2 will be your that will be your x, and or if you're going to start with 2 and 7, automatic your 2 will be your x, or x prime will be used. So if we're going to use the function of f, f of x, so therefore f is less than x and x is less than 7. So we're going to use the x prime minus a over b minus a minus the x minus a over b minus a. So bakit tayo gumagamit ng x prime? So because we are using two common variables na pwede nating comparison between the two variables. So automatic, so your first prime will be used with your original, and the second x will be used for the second optional minutes. So for the x prime, you're going to use the last point, no, between the 2 and 7. So ibig sabihin from 0 to 7 will be your starting. So a is equals to 0 and 7 will be your x prime, and then x prime, and then your second x or yung 2 will be your x, no. So we have the result of 7 minus 0. So we have 10 over 10 minus 0. So we're going to have 1 over 2, or this will be equivalent to 2 over 5. So 2 over 10 rather. So 2 over 10 in lowest term, that will be 1/2. So if you're going to use the function, so the lower is 2 limit, and we have the higher limit of 7, 1 over 10 minus 0. So we're going to have the d of x. So the prime natin, directly computation, 7. So that will be your x prime, and minus your x will be your 2. That will be equivalent to 5. And 10 minus 0 will be 10. So therefore 5 over 10. So that in lowest term, that will be equivalent to 1/2 also. So we have the exponential distribution. The most important application of the exponential distribution are situations where the Poisson process applies. Recall, the Poisson distribution is used to compute the probability of specific numbers of events during a particular period of space. In many applications, the period of span of space between events is the random variable of interest. The exponential distribution gives the probability that the x, the region of time of space between Poisson event, falls within a specified interval. The continuous random variable x has the exponential distribution with parameter of beta in its density function is given by. So we have the probability density function where f of x is equivalent to 1 over beta of with the given e, or we are given events with the exponent of negative 1 over beta of x. So by the use of cumulative distribution function, you're going to have your a, and your b will be your lower and the upper. Then indicate your probability density function, no, and it's equivalent to negative e raised to negative 1 over beta of x, or the b and a is less than x, and x is less than b. A is less than equal x. So you have your mean will be your beta, and your variance will be beta squared. Yan. So let's have a given comparison. In the Poisson distribution, the Poisson mean the parameter. So we have the Poisson was defined as the mean number of the events per unit or time space. In the exponential distribution, the exponential mean, or the parameter beta, may be defined as the mean amount of time over space between events. So the Poisson mean of exponential mean, therefore the following relationship. So the Poisson will be 1 over beta. So it means, following the same diniderive natin yung ating probability density function. So this will be your element, no, raised to your Poisson of element. So using the cumulative distribution function derive, so same pa rin your lower and your upper limit within a and b, then get the probability density function that was derived. So it's equivalent to, so make sure lang that a is equal to less than x, and x will be less than b. So in terms of mean, 1 over your Poisson, no, and will be your variance over y squared lang natin, no. So we have the given formula. We have the given example. Suppose that the study of the certain computer system reveals that the response time in the second has an exponential distribution with a mean of 3, and what is the probability that response time in less than 10 seconds, what is the probability that response time exceed 5 seconds. So we're going to use your beta, the mean amount of your time between 3 seconds. And your x will be the time of interest that is equivalent to 10 seconds. So if we're going to graph, no? So this will be your 10, yan, your interest of time. So we're going to use the formula or the function density of the probability density function. Just follow. So you're going to have your 1 over 3, no? That is according to this formula, your mean, no? So we have e raised to, so according to your formula, so i-raise mo lang siya sa ating element o dun sa ating Poisson method. So that will be equivalent to 1 over 3. So just copy, then 10, 0 from 10. So equivalent natin yan will be negative e raised to negative 1 quantity 10 over 3 minus the quantity negative e raised to negative 1 quantity 0 over 3. So you're going to have the result of 0.9643. So if you're going to use, you are required to use the scientific calculator for you to solve the given problem. So for letter B, so what will be the probability that response time exceed 5 seconds? So nag-exceed ng 5 seconds. So automatic magiging 0 from 5 na siya. So therefore, so 1 over 3, so ang mapapalitan lang natin will be the value of A and B. No, kanina kasi we have from 0 to 10, hanggang dito lang, then nag-exceed pa siya from 5 seconds. So dun lang mapapalitan lang din yun. So you're going to come up with, so ibig sabihin lumagpas na siya, greater na siya. So compare dun sa kanina nyo, yung x nyo is less than 10 dahil mababa siya sa 10, then lumagpas siya, so kaya siya naging f of x, yung x mo is greater than 5 na siya, mas mataas na siya doon. So automatic you're going to have your result using the scientific calculator of 0.1889. So we have the normal distribution. Undoubtedly, the most widely used for the model of distribution of a random variable is a normal distribution. Whenever a random experiment is replicated, the random variable that equals the average or the total result over the replicates tend to have a normal distribution. As the number of replicates become large, so we have the Moir represent the fundamental of result known as central limit theorem in 1733. Although de Moir was later credited in the derivation, a normal distribution is also referred to as by a Gaussian distribution. Random variables with different means and variables can be modeled by normal probability density function with appropriate choices of the center and width of the curve. The value of e sub x is equals to your given mean, yung ating mga derived mean, determines the center of the probability density function of the value of v sub x is equals to our variance raised to 2, determines the width. So for you to understand, so this is your z-score normal distribution. This is a normal curve. So enter the area of the curve of 100% or 1.0. So this will be your zero value. So it means from the right and left, they are almost perfect, no? The properties of the z-score normal distribution is symmetrical. Pag sinabi natin symmetrical, kung ano yung pagkaka-curve dito, is almost the same with your curve at the given other side. So your mean will be 0 and the standard deviation will be equivalent to 1. So mean, median, and mode are equal in this given data. So therefore, your your curve is a normal distribution. So for you to understand this, so the probability density function, just follow. So we have the given formula, and we have the standard normal distribution, so using the infinity, and the standard normal transformation, and the cumulative distribution function. So you have your mean and you have your variance. So sa CDF, so of the normal distribution is given the appendix G of this unit, the quantities of the middles of the table with the given probabilities of P of Z. So you're going to analyze this one. So this is the example. So according to our given table, yung source niya ay kay Montgomery Douglas. So applied statistic and probability for engineers. So ito yung sinasabi nilang normal curve, no? Or normal distribution. So where the probability of Z, so ito siya. So kung titigan din natin dito, nandito siya sa kabilang side na to, no? Okay. So you have your given distribution table. So you will identify whether the given P kung saan siya sakop, no? If you're going less than 1 or less than 3.4, then you're going to have the margin of error, no? Diyan sa ibabaw. Okay, so let's have a given example. Assume Z has a standard normal distribution. Use the normal curve table to determine the value of Z that solve each of the following. So, ang sinolve lang natin dito is yung letter A, no? Then, try to solve yung B, C, D, and E. So, this time, the probabilities given by the Z value is known. The first step is to look for the two quantities in the normal table which the given probability is in between this value. Then, no interpolation in using the function of calculator. So, kung titingnan natin dito, ito yung ating normal curve na P, yung Z natin is less than Z dun sa maliit is equals to 0.90. So, this will be your table. So, titingnan natin kung saan siya dyan. So, kung titingnan natin, so, ang table natin is nasa 1.2. No? Kung titingnan natin is 1.2 yung ating table, bakit nasa 1.2 dapat natin siyang tignan? So, your given is 0.899725 or 0.901475. So, nandun siya. 0.128 tsaka 1.129. So, dito yon. So, from 0.00 or negative 0.01, no, ang ating Z. So, ibig sabihin, dito sa ating given table is 1.28, no, and 1.29, no. Ibig sabihin, dun lang natin siya makukuha. So, ibig sabihin, using the, yung mag-intersect with each other, no, dun sa given table. So, kung titingnan mo dito, eto siya, sa 1.2, yan. Then, kung titingnan natin dun sa mismong taas, nandito siya. Yan. Sa 0.08 tsaka 0.09 dito siya. So, ibig sabihin, using the calculator, interpolate mode, ito yung ating magagamit nyo using your scientific calculator. Try to solve on your own. Just click the mode, then select the stat, then select this given function. Then you will see in your calculator, then input the given data. From number 1, you have the 1.28, that is equivalent to this given number, and 1.29, this will be your given number, and you're going to have your result of Z is equivalent to 1.2816. For number 2, assume that Z has a standard normal distribution. Use the following curve table to determine the value of C that solve each of the following. So we have your given P of 0.95. So try to recall the normal curve, symmetric. So ito siya, 0.95. So automatic this is 0.95 also. So that is equivalent. So the totals are equal in 1 minus 0.95, that is equivalent or divided by 2 is equals to 0.025. Yan. So that will be your formula. Ito yung 0.95, yung 1 lang dahil symmetrical siya, that is 1 minus the 0.25. So you're going to have your result of 0.5. 0.5 divided by 2, that will be your 0.025. The boundaries left side and right side. So you're going to have your result, no? Here's the result. So that is equivalent to 1.96 and 1.95. So this is 0.024, no? Or equivalent to tsaka yung 0.025. Yeah. So using the calculator again, just use your scientific calculator. Then you're going to have your result of positive negative 1.95997. Yan. So that's try to solve the another problem from B, C, D, E. No? Then I will give the correct answer. Yan. Then so that's the end of our lesson 4, and thank you and have a nice day.